Welcome to the notes for Chapter 6, Lesson 2. This is solving exponential equations without logarithms. We'll do it with logarithms later. So, in order to solve radical equations, and if you don't have a calculator or if you don't have if you're not allowed to use it or anything like that, you can always change the bases to be the same and then deal with your exponent and radical rules as they are. So, for example, 4 to the negative n minus 2 power equals 4 to the 2n plus 3 power. Because the 4's are already the same, everything else must be the same. So negative n minus 2 must be the same as 2n plus 3. If I add n and subtract 3 from both sides, then negative 2 minus 3 is negative 5 equals 3n. And then if we divide both sides by 3, then n must equal negative 5/3. But again, you might need to make other changes first. So 1 over 16 to the negative 2n power equals 1 over 4. Again, 16 is really 4 squared. So 1 over 4 squared to the negative 2n power equals 1 over 4. Again, 1 to any power is just going to stay 1. But 4 squared to the negative 2n power, we can simplify a little bit. So 1 over 4 to the 2 times negative 2n would be negative 4n equals 1 over 4 to the first power. And again, all the bases are the same, so that means that the exponents must also be the same. Negative 4n equals 1. So we'll just divide and find that n equals negative 1/4. Part C, 2 to the negative 2n equals 32. Well, let's see here. 32 is really 2 to the 5th power. So now again, the bases are the same, so we can just take the exponents and say that they must also be the same. So negative 2n equals 5, divide those by negative 2, and n equals negative 5/2. D, we've got some stuff that we need to simplify here. 1 over 36 to the n power times 216 times 3 to the 3n minus 1 power equals 1 over 216 to the 3n. So let's see here. 1 over 36 is really 1 over 6 squared. 216 is really 6 cubed, but that's getting raised to the 3n minus 1 power. And all that is going to equal 1 over 6 cubed, and all of that to the 3n power. So 3n minus 1, we will have to distribute this 3. So we get 6 to the 9n minus 3 power over 6 squared equals, again, if we turn this side into 1 to the 3n over 6 cubed to the 3n, we can multiply our exponents. So that's going to be 1 over 6 to the 9n. We can subtract our exponents. So if we need to subtract this 2 up here, we can also turn this 9n into a negative. We're going to get 6 to the 9n minus 5 equals 6 to the negative 9n, which now means that 9n minus 5 must equal negative 9n, or negative 5 must equal negative 18n, or if we divide by negative 18, we get 5/18 is the value of n. Part E, 16 to the 2x power times 4 to the 2x plus 2 power equals 2 to the third power. Smallest base is 2, so let's turn all these into bases of 2. So we have 2 to the fourth power is really 16 to the 2x times 4 is really 2 squared to the 2x plus 2 power, and that all equals 2 to the third power. So we'll raise our powers to powers. We will have to distribute a little bit up here, but we get 2 to the 8x times 2 to the 4x plus 4 equals 2 to the third. Now we are multiplying the same base, so we can just add the exponents. 8x plus 4x becomes 12x, still plus the 4. And now we have the same base. So now 12x plus 4 must equal 3, so that the exponents are also the same. If we subtract, then 12x equals negative 1, and then if we divide, x equals negative 1 over 12. Part F, 5 to the 2n over 5 to the n minus 2 equals 1 over 625. So we're kind of looking at this as 5 to the 2n minus n minus 2 power, and it's going to equal 625 is 1 over 5 to the fourth power. So if we simplify up here, then we get 5 to the 2n minus 1n minus negative 2 becomes n plus 2. And 1 over 5 to the fourth power, we can make that 5 to the negative fourth power by bringing it up. So that means that n plus 2 must equal negative 4, or n equals negative 6. Part G here, x plus 22 to the 3 halves power equals 729. Let's see here, 729 is really 81 times 9. Yeah. X plus 22 to the 3 halves power equals 81 times 9. 81 is really 3 to the fourth power, and 9 is really 3 squared. Here, let's just double check. Is 3 to the sixth power 729. Cool. So x plus 22 to the 3 halves. Well, one thing that we can do is we can raise both sides of this equation to the same power. We can raise everything to the 2/3 power, since 3 halves times 2/3 makes 1. So we're going to get x plus 22 equals 3 to the 6 times 2 is 12, but 12 divided by 3 is fourth power. So x plus 22 really equals 81, and this one I'll use my calculator for to speed it up. 81 minus 22, x is really 59. 100 equals 4 times 125n to the 2/3 power. So first thing I'm going to do is divide by 4. So that 25 equals 125n to the 2/3 power. Again, 125n to the 2/3 power is really 125 to the 2/3 power times n to the 2/3 power. 125 is really 5 cubed, so we're looking at the cube root of 5 cubed, but that's going to get squared times n to the 2/3 power. Again, cube root and the cube cancel each other out, so we're really just looking at 25 equals 5 squared times n to the 2/3 power, or 25 equals 25 n to the 2/3 power. If we divide off those 25s, then n to the 2/3 power equals 1, and 1 to any power is 1, so n must also be 1. Part I here, 17 equals 5 plus 4a to the 1/3 power. So if we subtract 5, then we get 12 equals 4a to the 1/3 power. And now we can divide by 4. So 3 equals a to the 1/3 power. To get rid of a 1/3 power, we want that to be a 1, so we can raise that to the 3rd power, but anything we do to one side, we have to do to the other side. 1/3 times 3 is 1, and then 3 cubed is 27. Let's move this part. So here we have 3v to the 3/2 equals 729, and again, 729 looks familiar. We just saw that up here in G. So 729 we just found out is really 3 to the 6th power. And we're going to have 3 to the 3/2 power times v to the 3/2 power equals 3 to the 6th power. I think I might square everything so I don't have to look at fractions, because 3/2 times 2 is just 3, and then 6 times 2 is 12, and now we can divide off that 3 cubed, so we get that v cubed equals 12 minus 3 is 9. And then we will take a cube root of both sides. Again, cube roots could be expressed as fraction exponents, 3 to the 9/3 power, and then 9 divided by 3 is really 3. So that means that v must equal 27. And then finally, 81x to the 3/2 power plus 2 equals 731. That's a very similar kind of problem. I'm going to take it a little bit differently, but a little bit similarly. So we have 81x to the 3/2 power equals 729. Again, 729 is 3 to the 6th power. And again, we could just take that whole thing and raise it to the 2/3 power, and anything we do to one side, we have to do to the other side, because again, 3/2 times 2/3 cancels out. 6 times 2 is 12, but 12 divided by 3 is 4. But hey, 3 to the 4th power is really 81, so if we divide, then x equals 1.